Chemistry. We are going to spend the next 3 units or next 3 lessons and rather wrap up the foundations unit with 3 lessons that deal with how chemical compounds are named, and we'll start with ionic compounds. So ionic compounds consist of a cation, a metal, and an anion, a nonmetal. When naming ionic compounds, the cation is named first and retains its original name. The anion is named last, and the end of the anion's name is changed to IDE. So examples: sodium and chlorine. So sodium is the metal, chlorine is the nonmetal. Sodium will give up an electron to chlorine. The sodium will become a positive cation, and the chlorine will become a negative anion, and they'll attract each other. So then the name of the cation, once the ionization takes place, is still sodium for the metal. For the anion, for the nonmetal chlorine, it becomes chloride. The compound formula is NaCl. This is table salt, and so the name is sodium chloride. Potassium, metal. Fluorine, the nonmetal. Potassium retains its original name, potassium, and fluorine becomes fluoride. So that's Kf is the chemical compound, and it's called potassium fluoride. Magnesium, oxygen. Magnesium retains its original name, oxygen becomes oxide. And that's MgO, magnesium oxide. Lithium and sulfur, lithium sulfide, Li2S, and lithium sulfide is the name of that compound. Some transition metals have more than one charge state. For example, iron, Fe, can be ionized to a 2+ or a 3+ charge, meaning that the atom loses either 2 or 3 electrons, so that it has 2 more protons or 3 more protons than it does electrons. When naming an ion with more than one charge state, a Roman numeral is used in the name. So you should know the Roman numerals up to at least 4, so I is 1, II is 2, III is 3, IV is 4, and V is 5. And as you may know, the way Roman numerals work is if you put a smaller number in front of a larger number, it subtracts. So if you take IV, that's the V is the bigger number, the 5, you put a 1 in front of it, an I, it becomes 4. So it's 5 minus 1 is 4. Iron can form 2 different compounds with oxygen. So let's look at those two. So iron, oxygen. So if we use the iron 2, the 2+ charge iron, it's called iron with a Roman numeral 2. The oxygen becomes oxide. So it's FeO because the 2+ of the iron matches up evenly with the 2- of the oxygen. So you have no subscripts there. And so that's called iron 2 oxide. That's the way you would say it, iron 2 oxide. Same 2 elements here, iron and oxygen. Now we're going to use the 3+ charge. So that now you have iron 3+ matching up with oxygen, which still has a 2- charge. So you'd have to use the crossing arrows method for this. So the oxygen still changes to oxide. And so now you have Fe2O3. So the irons each have a charge of 3+. You have 2 of them, so that's a charge of 6+. The oxygen has a charge of 2-. You have 3 of them, so that's a charge of 6-, so 6+, 6- balance out. And so you're going to call that iron 3 oxide. Don't get confused by the subscript of iron being a 2. You use the 3+ charged iron in this case, so it's iron 3 oxide. Some more examples. Copper and fluorine. So we're going to use the 2+ charge of copper. You can look on your charge number by ion sheet or on your 60 common ions and see that copper can have 2 different charges. So we're going to use copper 2. The anion is going to become fluoride. So it's CuF2. The copper's a 2 plus. Each fluoride is a 1 minus, so you need 2 of the 1 minuses to match with the 2 plus. So that's going to be copper 2 fluoride. Titanium, chlorine. Titanium has one of its charges is a 4, titanium 4. And chloride has a charge of -1, so you're going to need 4 chlorides to match up with 1 titanium 4. So it's TiCl4, and that's titanium 4 chloride. Cobalt, bromine, we're going to use cobalt 2 plus. Bromine has a 1 minus charge, so you're going to need 2 bromines to match up with the 1 cobalt, and that's cobalt 2 bromide. Okay, let's look at a few others. There's an alternate nomenclature for transition metals with 2 main charges. This is kind of old-fashioned and archaic. I won't test you on this, but you'll see it on the assignment. So the lower charge number uses the suffix OUS. The higher charge number has the suffix IC. So let's take iron, for example. Iron has a 2 plus and a 3 plus charge. So the 2 plus iron would be called ferrous. The 2 plus charge would be called ferrous. The 3 plus charge, that's the higher, would be called ferric. So FeO. So that has to be the iron 2 to match up 1-to-1 with an oxygen. Again, if this iron has a 2 plus and the oxygen has a 2 minus, then it's Fe1O1, so it's just FeO. So we know we're using the 2 plus. That means it's going to be the lower charge number, so it's going to become ferrous. So it's iron 2 oxide, but the other name would be ferrous oxide. Okay, now we're using the higher charge number for iron. That's the 3 plus. We saw this on the previous slide. So the higher charge number is going to be ferric. So it's iron 3 oxide. That's generally what we will always call it, is that name in the middle. But that would be ferric oxide. Copper 2 and oxygen. So that means the copper in this case has a 1 plus charge. That's the lower of the 2 charges that copper can have. So it's copper 1 oxide. So what's that going to be? If it's the lower charge for copper, it's going to be cuprous oxide. Now we have copper matched with an oxygen 1-to-1. The oxygen has a -2 charge. That means this copper has to have a +2 charge. So it's copper 2, and so that's going to be copper 2 oxide is going to be cupric oxide. Okay, here's lead chloride. Okay, so the lead, if there's 4 chlorines or chlorides and they all have a 1 minus charge, that's a 4 minus. That means we must be using lead 4. Again, look on your charge number by ion or your 60 common ions, lead 4. So that's lead 4 chloride. And 4 is the higher of the 2 charges that lead can have, so that's going to be an ic. So that's going to be plumbic chloride. That's what the PB in lead stands for, is plumbic. It's a Latin word. Okay, now you have sulfur is a 2 minus. So that means the lead, if it's matching up 1-to-1 with the sulfur, it's got to be a 2 plus. 2 plus for lead, 2 minus for sulfur, matches up 1-to-1. Okay, so that means the lead has to be the 2 plus. That's the lower charge. So that's lead 2 sulfide. And that's plumbous sulfide. Tin and oxygen. So that if oxygen has a 2 minus charge, that means this tin must have a 2 plus charge, because you can see they're matching up 1-to-1. No subscripts. Okay, so that's tin 2 oxide, and that's the lower of the 2 charges for tin, so that's going to be stannous oxide. Now you have the higher of the 2 charges for tin. You have fluoride, that's a 1 minus, so 4 of those is a 4 minus, so that means that tin must be a 4 plus. So it's tin 4 fluoride. That's the higher of the 2 charges for tin, so it's going to be stannic fluoride. Now we have mercury oxide. and mercury and oxygen. So the oxygen is always a 2-. That never changes. That means the mercuries, if there's 2 of them, must be 1+ each. So 2 times 1+ equals 2+. That's going to match up with the oxygen, which is always a 2-. So that's going to be mercury 1 oxide. And that's the lower of the charges for mercury. So that's going to be mercurous oxide. Finally, we have mercury and sulfide. Sulfide is a 2- always. So that means this mercury, if they match up 1 to 1, must be a 2+. So that's going to be mercury 2 sulfide. And that will be mercuric sulfide. And that takes care of our lesson on the naming of ionic compounds. We'll learn about covalent and molecular ions in the next 2 lessons.